The only difference for approval between service equipment and service entrance equipment is the bonding means. Service equipment protects a building's electrical system from overcurrents and short circuits, often including a main breaker or fuse and a neutral bus bar. Service entrance equipment connects the building's electrical system to the utility grid, and it typically includes a meter, a main breaker or fuse, and a main disconnect switch. The bonding means refers to the method used to connect the neutral busbar to the grounding electrode system. In service equipment, the neutral busbar is generally bonded to the grounding electrode system by a bonding jumper. Conversely, in service entrance equipment, the neutral busbar is typically bonded to the grounding electrode system by a grounding electrode conductor. To delve deeper, let's clarify some key terms. Firstly, the grounding electrode system is a network of interconnected grounding electrodes designed to provide a low impedance path for fault current to return to the source. Secondly, a grounding electrode conductor connects the grounding electrode system to the service equipment or service entrance equipment. Thirdly, a bonding jumper is a conductor used to connect metallic parts together to ensure electrical continuity and conductivity. Now, let's explore the reasoning behind the distinct bonding methods. Service equipment, being located within the building, requires a direct, low impedance path to ground for safety. This is achieved via the bonding jumper. The bonding jumper connects the neutral busbar to the equipment grounding conductor, which is connected to the grounding electrode system. This ensures that any fault current will quickly trip the overcurrent protective device, such as a breaker or fuse, minimizing the risk of electrical shock. Service entrance equipment, on the other hand, requires a different approach. The grounding electrode conductor serves as the primary connection to the grounding electrode system. This conductor is sized based on the size of the service entrance conductors according to the National Electrical Code, or NEC. The grounding electrode conductor provides a path for fault current to return to the source, as well as a path for lightning and other transient voltages to ground. It is vital to adhere to the NEC guidelines for sizing and installing grounding electrode conductors and bonding jumpers. A proper installation can lead to dangerous situations, including increased risk of electrical shock and equipment damage. To elaborate further, consider a scenario where a fault occurs in the electrical system. If the bonding is not properly implemented, the fault current may not be able to return to the source quickly enough. This can result in a sustained voltage on metallic parts, creating a shock hazard. Additionally, the fault current can cause equipment to overheat and potentially start a fire. The NEC provides specific requirements for grounding and bonding to minimize these risks. These requirements are based on extensive research and testing, and they are designed to ensure the safety of people and property. For example, NEC Section 250.24 C specifies the requirements for grounding the neutral conductor at the service. This section outlines the acceptable methods for connecting the neutral conductor to the grounding electrode system. Similarly, NEC Section 250.28 provides requirements for bonding metal enclosures and other metallic parts. This section ensures that all metallic parts are electrically connected together, providing a low impedance path for fault current. The size of the grounding electrode conductor is determined by NEC Table 250.66, which is based on the size of the service entrance conductors. It is crucial to select the correct size conductor to ensure that it can safely carry the fault current. The size of the bonding jumper is determined by NEC Table 250.102 C1, which is based on the size of the largest and grounded conductor. Again, selecting the correct size jumper is essential for safety. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions for installing service equipment and service entrance equipment. These instructions provide specific details on how to properly ground and bond the equipment. It is worth noting that the requirements for grounding and bonding can vary depending on the type of electrical system. For example, the requirements for a separately derived system, such as a generator or transformer, are different than the requirements for a service entrant. It is essential to understand the specific requirements for the type of system being installed. Another important consideration is the type of grounding electrode system. There are several different types of grounding electrodes, including ground rods, ground plates, and concrete encased electrodes. The NEC specifies the requirements for each type of grounding electrode. For example, NEC section 250.52 A5 requires that ground rods be at least 8 feet long and be driven into the ground to a depth of at least 8 feet. It's important to remember that proper grounding and bonding is not a one-time task. It is necessary to periodically inspect and test the grounding system to ensure that it is still functioning properly. This includes checking the connections to the grounding electrodes, as well as testing the impedance of the grounding path. In summary, the difference between service equipment and service entrance equipment lies in the bonding means. Service equipment utilizes a bonding jumper to connect the neutral busbar to the grounding electrode system, while service entrance equipment employs a grounding electrode conductor. Understanding and adhering to the NEC requirements for grounding and bonding is crucial for ensuring electrical safety and preventing equipment damage. Remember to always consult with a qualified electrician for any electrical work, and to always follow all applicable codes and regulations. Proper grounding and bonding are fundamental to a safe and reliable electrical system. The information provided is a general overview and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific applications and to ensure compliance with all applicable codes and standards. The NEC is updated every 3 years, so it's important to stay current with the latest edition. Changes in the code can affect the requirements for grounding and bonding. Furthermore, local jurisdictions may have additional requirements that must be followed. Therefore, it's essential to check with the local authorities to ensure compliance with all applicable codes and regulations. One aspect of grounding that is often misunderstood is the concept of impedance. Impedance is the opposition to the flow of alternating current. A low impedance grounding path is essential for quickly clearing faults and minimizing the risk of electrical shock. The impedance of the grounding path is affected by several factors, including the size and material of the conductors, the length of the conductors, and the connections between the conductors. Therefore, it is important to use high-quality conductors and connectors, and to ensure that all connections are tight and corrosion-free. Another important consideration is the coordination of overcurrent protective devices. Overcurrent protective devices, such as breakers and fuses, are designed to interrupt the flow of current when a fault occurs. However, it is important to ensure that the overcurrent protective devices are properly coordinated to prevent nuisance tripping. Nuisance tripping occurs when an overcurrent protective device trips unnecessarily, causing a disruption of power. Proper coordination of overcurrent protective devices can be achieved by selecting devices with appropriate time current characteristics. The time current characteristic of an overcurrent protective device is a graph that shows the amount of time it takes for the device to trip at different levels of current. By selecting devices with appropriate time current characteristics, it is possible to ensure that the device closest to the fault will trip first, minimizing the disruption of power. In addition to grounding and bonding, surge protection is another important aspect of electrical safety. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, switching transients, and other events. SPD work by diverting the surge current to ground, protecting the connected equipment from damage. There are different types of SPD available, including whole house SPD and point of use SPD. Whole house SPD are installed at the service entrance and protect the entire electrical system from surges. Point of use SPD are installed at individual outlets or pieces of equipment and protect those specific devices from surges. It is important to select SPD that are appropriate for the application and to install them according to the manufacturer's instructions. Proper grounding, bonding, overcurrent protection, and surge protection are all essential components of a safe and reliable electrical system. By understanding these concepts and following the NEC requirements, it is possible to minimize the risk of electrical shock, equipment damage, and fire. Remember to always consult with a qualified electrician for any electrical work and to always follow all applicable codes and regulations. A good electrician will not only be knowledgeable about the NEC but will also have experience in applying the code in real-world situations. They will be able to assess the specific needs of the installation and recommend the appropriate solutions. They will also be able to perform the necessary testing to ensure that the electrical system is safe and functioning properly. Choosing a qualified electrician is an investment in the safety and reliability of the electrical system. Take the time to research and select an electrician who is licensed, insured, and has a good reputation. Don't be afraid to ask questions and get multiple quotes before making a decision. The safety of people and property depends on the proper installation and maintenance of the electrical system. Therefore, it is essential to take the necessary steps to ensure that the work is done correctly. Keep in mind that electrical codes and standards are constantly evolving, so it's important to stay informed about the latest changes. There are many resources available to help you stay up to date, including the NEC industry publications and online training courses. By staying informed, you can help ensure that the electrical system is always safe and in compliance with the latest requirements. Let's summarize the key points regarding service equipment and service entrance equipment. The primary distinction lies in the bonding method. Service equipment employs a bonding jumper to connect the neutral bus to the grounding electrode system, whereas service entrance equipment utilizes a grounding electrode conductor. Understanding the NEC requirements for grounding and bonding is critical for ensuring electrical safety and preventing equipment damage. Always consult with a qualified electrician for any electrical work and adhere to all applicable codes and regulations. Additionally, remember the importance of surge protection, overcurrent protection, and proper coordination of protective devices. Regular inspection and maintenance of the grounding system are also essential for long-term safety and reliability. Consider these guidelines as foundational knowledge for working with or understanding electrical systems. They should not be considered a substitute for professional training or guidance. Always prioritize safety and consult with qualified professionals when dealing with electrical installations and maintenance.